right, y'all, this is not new. This is an old topic, but it's kind of, it's important that we go over it. So this is why this is titled Prerequisites. So these were the exponent rules that we did first semester. And so we're going to practice this, and I'm going to go over the rules again. So when we have two bases, they're the same. So this is the same base. They're both base of A, and they're to a power. We add that exponent. So an example of that would be x squared times x cubed would be x to the fifth. So see, I'm adding these exponents, I'm not multiplying it. So it's x to the fifth, not x to the sixth. When we have an exponent to an exponent, so we have a power to a power, now we actually multiply. So if I use those same two numbers, this becomes x to the sixth. So 2 times 3 is 6. Okay, so when we have two things inside of the parentheses. These could be variables, these could be numbers, or actually it would be a number and a variable. To an exponent, we distribute this exponent to both terms that are in there. So an example of that might be 3x squared, for example. And if I did that, then the 2 goes to the 3, so that would be 9. And the x squared is to a power, so I'm going to multiply this, so I would have x to the fourth. Okay, a negative exponent means move. So when we have a negative exponent in the top, we move it to the bottom. If we have a negative exponent in the bottom, we move it to the top. And then when we move it, it becomes positive. So for example, if I had x to the negative 2, this would become 1 over x squared. If I had something like 1 over y to the negative 3, this would become y cubed. So when we move it to the denominator, it becomes positive. If it's negative in the denominator, we move it to the numerator and it becomes positive. Okay, this next one is anything, it doesn't matter if it's a number, if it's a variable, anything to the 0 power equals 1. So if I have 122 to the 0 power, this still equals 1. If I have xy to the 0 power, this whole thing equals 1. Okay, so here when I'm dividing exponents with the same base, so this is same base division, then we subtract our exponents. So an example of that would be x to the fifth over x cubed. This would be the same as x to the 5 minus 3, which is x squared. Now another way to look at it is you have 5 x's on the top and you have 3 x's on the bottom. So you're going to have more x's on the top. So because you have more on the top, how many more? You have 2 more. And that's why this is in the numerator. I have no denominator here. Okay? And then last one. Again, when I have this parentheses up here, I distribute to both terms. Here I have parentheses, I still distribute to both terms. So if I had, for example, I don't know, x cubed over, or x squared over y squared, and this is cubed, this would be x to the sixth over y to the sixth. So it would go to both terms. Okay, so here's some numbers. We're going to just work through these. And what we're looking for on all these when it says simplify is you want to combine same base. That's what we're looking to do. So here my bases are x. Because I'm multiplying, I add. So I get x to the 16. And here my bases are y. And so when I add that, I get y to the 21. And that's my final answer. Now with this next one, what we see is that we have this exponents on the outside, so it's like distributing to every term on the inside. So 3 squared is 9. 8, and now what I'm going to do is multiply. So 8 times 2 is 16. 9 times 2 is 18. And 3 times 2 is 6. So when we distribute it to a number, then we actually square it. We would have 3 squared, which is 9. But when we're looking at our bases, we're going to multiply. And that's what we had up here. So when I took this to the 3, I got the 9. But here what I'm doing is multiplying, and that's where the 4 comes from. Okay? Now, here, the only thing that's negative is the s. It's the only thing that's negative. So only the s is moving. So this ends up with 3r over s. So here's my final answer. Now, if all of it was moving, it would look like this, 3rs to the negative 1. And this would be 1 over 3rs. So it's important that you see if there's no parentheses, the only thing that's negative here is the s. All right, let's go through a few more of these. Here, what I'm doing is I'm dividing. So when I divide, I'm going to subtract. Now, instead of subtracting and having negative 5 minus 10, I'm going to look at this and say, okay, I have an x and an x, 5 on the top, 10 on the bottom. That means I've got 5 more on the bottom. So I'm still subtracting, but instead of making it a negative number and then moving it, I'm just looking at this problem and saying, okay, I have 5 on the top and 10 on the bottom. So I have 5 more, and where are those 5 more? They're in the denominator. So I'm going to do the same thing here. 8 on the top, 4 on the bottom. So I have 4 more, and where are they? They're in the top. So y to the 4th. Okay, this one looks awful, but it's not because anything to the 0 power is 1. So there's nothing to do on that one. It's easy. Okay, so you can do this 2 different ways. You can simplify inside the parentheses first, and then you can take it to the 5th power, or you can take it to the 5th power and then simplify. So I'm going to simplify inside first. So I only have a y in the numerator, so the y stays. I only have this 2 in the denominator and a z in the denominator. But I have an x here, and I have an x squared on the bottom. That means I have 1 extra x, and it's down here. And this whole thing is to the 5th power. So now, if I look at this problem, what I have here is y to the 15 over 2 to the 5th power. So 2 to the 5th power is 32, and that's one that you should be able to do because you're doubling. So 2, 4, 8, 16, 32. And then I would have z to the 40 and x to the 5. All right, here what I have is 2 different terms that are all multiplied together. So what I'm going to do is I'm just going to multiply all these together, and when I multiply these together, I'm going to add. So if I was to put the x to the 5th and the x together, I add the exponents because I'm multiplying. So this becomes 20, x to the 6th, y to the 6th, z to the 13. Sorry, there was something going on with my camera. Okay, so for number 8 here, I'm going to move everything around because the goal here is I'm going to make everything positive. So if I make everything positive, I'm going to have a 3. This x squared is going to move to the denominator. I have a y that stays positive, it's in the numerator, and I have a z that's negative, so it moves to the denominator. Okay, so now I'm going to go to the denominator. X to the negative 1, so to make it positive, it moves to the numerator. Y to the 5th is going to stay in the denominator, and z is going to stay in the denominator. So now that I've done this, I can go in and simplify. So I have a 3 in the top. I have 1 y here and 5 y's here. So this becomes y to the 4th. I have 4 extra ones. Where are they? They're in the denominator. I have 1 x on the top and 2 on the bottom. So I have 1 x that's left in the denominator. And then I have 3 z's and 1 z, so I have z to the 4th. This is my final answer. And I know I'm going through this quick, but again, we did this first semester, so hopefully this is all review. Okay, now with this guy, I'm going to move this negative first. I know I've got more things going on in here, but I'm going to do this first. So what this means, because this is a fraction, this means I'm going to flip it. So I end up with s cubed over r to the negative 2 cubed. Now, technically what this is it's 1, when I make this positive, it would be 1 over this guy, and we know that what that means when we have a fraction is that we flip it. We have the reciprocal fraction. So when I get the reciprocal, this becomes positive. And now I'm going to do one more step, and I'm going to make this negative a positive. So I have s cubed, r squared, all to the 3rd power. And now I can distribute this through. So I have s to the 9th, r to the 6th. Okay, again, we did this first semester. You need to know these without a calculator. And you need to know these so that you're not going to forget them, because they're going to come back next year. So most of you can do this up to 12. So 11 squared is 121, and 12 squared is 144. But you need to know 13, 14, 15, and 20. So this becomes 169, 196, 225, and 20 squared is 400. So just go in, memorize these, put them on a note card if you need to, but you've got to have them. Now this is cubed. So anything that's cubed is multiplied by itself. So 1 cubed is 1. This is going to be 8. 3 times 3 is 9. 9 times 3 is 27. 4 times 4 is 16. 16 times 4 is 64. And then this one, 5 times 5 is 25. 25 times 5 is 125. And so, again, if you need a logic through, like I just spoke through them, but you've got to know these. Now, this is a negative exponent. So what happens when we have a negative exponent? It means we move it. So 2 to the negative 1 is 1/2. This is the same as 1 over 2 squared, which is 1 over 4, which makes this one 1 over 8. Right? I'm just moving this. So this becomes 3 squared in the denominator, and we just say that 3 cubed is 27. Okay, hopefully this was all review. If not, come see me.